All right, as we get started today, I want to quickly review something with you. If I have an expression like this, what do we call this little raised number, class?
Exponent.
Exponent. What do we call the number that has an exponent?
Base.
The base. All right, so this is actually read 9 to the third power, or better yet, a lazier way to say it would be what, Elaine?
9 cubed.
9 cubed. What does 9 cubed actually mean, Corey? What does it mean when we say it's cubed?
It means 9 times 9.
There we go, 9 times 9 times 9. And so if you were asked to evaluate 9 cubed, you'd say, well, 9 times 9, class, is 81. And then we'd multiply 81 times 9 to get 729. 9 times 1, 9, and 9 times 8, 72. What if we had something like 2 to the 7th power? Well, what does 2 to the 7th power literally mean, Joel?
2 times 2 times 2 times 2 times 2 times 2 times 2.
There we go. And said with such energy and enthusiasm, too. All right. And now I'll be honest. I'm like, I ain't going to multiply all that stuff out. But what I could do is I could pair these two up, class, and make it a
4.
And these to another
4.
And these to another
4.
And this lonely little 2 is just still a 2. And then 2 times 4 is 8. And 4 times 4 is 16. And 16 times 8 might be easier than tracking all those 2's here. We end up getting, be careful when you carry the 4, class, 128. Your speed drill today is going to involve multiplying things out using exponents. So have everything off your desk except for a pencil. So we will do speed drill 47. Speed drill 47 today, practicing with exponents. If you need extra paper, if you feel like, yeah, I write big, I'm going to need some extra space, you can get out an extra blank sheet of paper to help you with this speed drill. So turning over to page 22, speed drill number 47. You have 10 exponents that you're going to have to solve, or 10 exponent expressions that you're going to need to solve. You'll have 3 minutes for these. Do the easy ones first, right? If you come across one like, yikes, okay, skip that one and do the easy ones, right? You'll have 3 minutes. You may begin. next up. All right, pencils away. Pencils off your desks, and have out a pen. Exchange with the person behind you, person in the back, bring yours to the front. Sign your name is greater, if you would please, next to where it says, what seems to be the problem? Okay, we're all good now? Okay. Sign your name is greater. Next to where it says speed test 48, there at the bottom of speed drill 47. These are 10 points each. The first few of these were really, really easy, so hopefully you raced through those in good time. 6 squared, 36. We've known that for years. 5 squared, 25. We've known that for years. Number 3, 11 squared, 121. We've known that for several years at this point. 3 cubed, well, 3 times 3, 9 times 3, 27. That should be no trouble at all. And then they throw a 7 to the 4th at us. Well, 7 times 7, 49 times 7, 343 times 7 more. 2,401. 2,401 is our answer. Pay attention. Number 5. 7 to the 4th. I read you the first 4 answers, so you should have been following along, so it would therefore be the next answer. Number 6, next row going across. 19 squared. Well, it's only 2 things to multiply, just 19 times 19. 361. 361. 8 to the 5th. Yeah, probably doing this one last. Okay, 8 to the 5th is 32,768. 32,768 for those who attempted it. If you ran out of time, this would have been the one to skip. 4 cubed, okay, that's not so bad. 4 is a small number. It's only 3 4s, 64. 64. 13 squared, okay, that one's not too bad either. 169. 169. And then 25 cubed. Well, 25 is not a hard number to multiply. There are 3 of them. It gives us a bigger answer. This might have also been one of those I wait a little later to do. 15,625. 15,625. All right, 10 points each. Figure the score, put it in the score blank, and return to the owner. Pass it forward to the owner, unless you're at the front of the row, then of course take it to the back of the row. Also be sure to write it in the score space next to where it says speed drill 47. And you notice as you write it in, there are only 3 more left this school year. All right, now that we got them back, any hundreds today? Any hundreds? There were a couple really big ones in there, so that's pretty impressive. How about 90s? Just missed one of those big ones. How about 80s? You got all but maybe those 2 larger, annoyinger ones. 70s still passed, a decent showing. Questions? Any questions? Do we need to see any of them shown? Yes, sir.
I accidentally put the answer to number 5 and number 10 on accident, so I got both wrong.
Ah, okay. I may be able to give some partial credit back on that. We'll see. I just have to see the work. Yeah, number 5 to 7 to the 4th. So with 7 to the 4th, the first thing I would always do is I would write it out first. That we don't accidentally forget one or multiply too many. We know 7 and 7 is 49. If you wanted to, you could actually cross this out, make another 49, and multiply it that way. That's one way to do it. The other way would be to simply say, okay, 7 times 7 is 49. And then 7 times 49, that's 3, carry the 6. Okay, 343. And now one last 7 and finish with a 7 times 343. Yes, sir?
What was the answer?
2,401. 2401. Any others? Any others? All right, pass those forward if you would, please. And take out your textbooks. Turn to page 404. Page 404. We have a test coming up on Wednesday in this class. For those watching on YouTube, it's lesson 163. Test coming up Wednesday in lesson 163, all about graphing and then just a little bit of algebra that we started looking at yesterday. We'll go over more today. We'll look at a little bit more on Monday. But just a couple of algebra concepts, and then the graphing is the big part of this next test. Test 11 coming up in lesson 163. Yesterday, Griffin, we're pretty much going to recap. So what you missed yesterday, we're going to be practicing more of today. So what you missed out on practice, you shouldn't miss out on the actual instruction side of things. We began looking yesterday at algebraic terms compared to each other. And we said that a term consists of a number called, usually class, the
Variable.
a number is a variable? Well, sometimes it's called a constant if it's just by itself. But if it's with letters as well, we call it the numerical coefficient. So a term consists of a numerical coefficient and then some letters, which we refer to as
The
variables, or collectively as the literal coefficient, right? Either name would work there. Well, we said, Griffin, that two terms, if they have exactly the same letters, Griffin, exact same letters, same exponent, same everything, the numbers can be different, the numerical coefficients may be different, but if the letters are exactly the same, we said, class, that those terms are said to be like terms. If the letters are the same, class, they are like terms. And when I say letters, for instance, Griffin, if I said something like an 8x cubed y and a negative 4xy squared, well, if I were asking a third grader, they would say, well, those letters are the same. But we know they're not, because this isn't just an x and a y. It's three x's and a y, right? And this aren't just x's and y's, it's an x and two y's. If I expanded it out, even the younger student would say, yeah, those aren't the same, are they? So the letters have to match, but they also have to have the same powers. These would not be considered like terms. But if I had something like a positive 6xy squared, well, that would be like, Griffin, to which of the other terms on the board?
Negative 4xy squared.
Good. These two would be considered like to each other because their letters match. Does that make sense? So as we look at the homework on page 404, have your homework out, books open to page 404. You did numbers 1 through 30. In the first section, you were simply supposed to state, are these like or are they unlike? And number 1, Kirsten, they are like terms to each other. Very quickly turning to page 404. Number 2, what would those terms be, Jalen? Unlike. Number 3, like or unlike? Elaine?
Unlike.
Unlike. Number 4, like or unlike? Luciana?
Unlike.
Unlike terms. Number 5, Corey?
Like.
Like terms. And number 6, Bryson? Also like terms. Questions on the like, unlike thing, Corey, or excuse me, hi Corey. Griffin, first of all, any questions at all on that? From the rest of us, any questions on that top section? All right, looking at the bottom, asked this, is the polynomial simplified or not simplified? For this, Griffin, if we were to have, let's just say, Griffin, that although it's kind of written spread out, let's just say this was my polynomial. Well, this is right now written with 3 terms. Class, 3 terms is called a trinomial. But, Griffin, we lazy. We don't want to have big, long, nasty-looking things. So if we can simplify something by maybe combining these 2 terms together, we would want to. And the way we combine them is we would say, well, negative 4xy squared and positive 6xy squared combined. They're like terms. I really ignore the letters for a moment and just add these 2 numbers. Negative 4 and positive 6, Griffin?
2.
Positive 2. And then the letters that were with them just kind of stick around. Okay? And so this answer is no longer a trinomial, it's simply class A binomial. And this is simplified. We simplified by combining things that could combine. So in the next section we were asked, is that simplified or is it not simplified? Well, number 7, Joel, it's not simplified. Those z's could be added together to get a 13z, and they ain't done that yet. How about number 8, Michael? It is simplified. You can't make that any simpler than it already is. Those things aren't going to combine. How about number 9, Ben?
Not simplified?
What could you do to simplify it? How could you combine those 2 terms?
No.
Oh, so if you can't combine them, then it is simplified already, right? It's already been simplified as much as it can be. How about number 10, Kirsten?
Not simplified.
Yeah, those A's could be combined still, so it has not been simplified yet. How about number 11, Jalen? Not simplified. The 2 K terms could be combined to get a 23K, so it also has not yet been simplified. How about number 12, Elaine?
Unsimplified.
Unsimplified or not simplified, because we could combine the negative 8R and the positive 7R. Now we understand as we look at number 12, Griffin, the Q, it can't be combined with anything else. But at least the 2 R's could have been combined together. Does that make sense? Questions on 7 through 12 from the rest of you now. Again, I'm directing a lot of this to Griffin because he's been out for a few days, but questions for the rest of us? Looking at the next section now, they wanted us to simplify the expressions down, combine things together. And it says something about conventional order. We're going to get to that in just a moment. But for number 13, really straightforward. Griffin wasn't even here, but Griffin knows the answer to 13.
Wait.
My confidence meter's dropping. It's okay. Luciana, what do we get if we combine the like terms on number 13?
17y.
17y, a 5y and a 12y add to get a 17y. Think of it this way, Griffin. If for some reason I had little letter y's in my hand, I don't know, little pieces of paper that were cut out, I'd fit 5 of them in one hand and 12 in the other. What do I have? I have 17 y's, right? 5 y's plus 12 more y's. Why would I have so many y's? For all of you who ask why, I don't know. Anyway, you ask, I get. Anyway, my wife did this as an April Fool's joke one year. She asked her class if they would like brownies. I said, yeah, we would. So what she'd done ahead of time was she had little e's, little letter e's in brown cut out, and she handed them little letter e's that were brown e's. Dumb joke. Anyway, yes. You may. Number 14. What do we get when we combine like terms, Corey?
7n.
7n. We understand that the 1n and 6n combine to give 7n. We know that we have that understood 1 numerical coefficient. How about number 15? Bryson?
7g squared.
7g squared. Number 16, Joel?
4m to the 4th.
Good, 4m to the 4th. How about number 17, Michael?
7b.
7b. And number 18, Ben?
I'm pretty sure I didn't do it right.
What'd you get?
5d plus. I put them in order because that's how.
Well, we want to combine them, though. So let's combine them together. So you have 29 d's. You take away 5. A negative 5d would take you down to what?
24.
24d. And then take away another 60, or negative 60. Class? 18d would be our answer there. Now, number 19, they're not all like terms, are they? Which two terms are like to each other, though, Ben, on number 19?
8 and 3w.
The 8w and the negative 3w. Those two terms are like to each other, so those two terms can be combined. What do we get if we combine just the 8w and negative 3w, Ben?
5w.
Positive 5w. And then the 4 has no friends, but class, even though it's all by itself, we still keep it. We don't lose the 4. Now here's the question. Do I write the 4 in front of the positive 5w or after the positive 5w, Ben?
Behind.
Behind it, because we always put the constant class at the end of the polynomial. Looking at number 20, we can combine a couple of these terms together, Jalen.
4k cubed.
I didn't ask for the answer. We can combine a couple of these terms. Which two terms?
12k cubed and negative 8k cubed.
Good. I'm glad she didn't say 12k cubed and 8k cubed. It's a 12k cubed and a negative 8k cubed. Very good. When we combine those two like terms, we get
4k cubed.
4k cubed. And then there's a lonely little term with no friends.
3k.
Positive 3k. Where do I put the positive 3k? Before or after?
After.
What kind of order? What was that term I gave you yesterday, class, for having the bigger exponent first, the smaller exponent later? Do you remember? Descending order. Class, say that with me? Descending order. So we sometimes want alphabetical order, sometimes we want a descending order, and sometimes it's just make sure the constant is at the end. Looking at number 21, there are a couple of like terms here, Kirsten.
P and P.
The positive 1p and the other positive 1p. And if those two things combine, we would get
2p.
positive 2p. Now, where do I put the w that is friendless?
After the 2p.
After the 2p, because w comes after p in the alphabet. What about the negative 3 that's friendless?
After the w.
Even after the w, because the constant always comes at the end. How many perfect on the first 3 in that little grouping? 19, 20, 21. We got them combined, and we got them in the correct order. Any questions on 19, 20, or 21 before we keep going? Any questions? Yes, ma'am? Oh. All right, any questions? All right, let's take a look at number 22. What can be combined on number 22? Joel?
Positive 3w with positive 2w.
To get what?
5w.
Positive 5w. But the other two terms are friends as well. They're like terms also. What do they combine to give you?
3z.
A positive 3z. Now, where do I put the 3z? Before or after the 5w?
After.
after, so that we keep the letters in alphabetical order. Looking at number 23, which terms can we combine together here, Bryson?
4B and 5B.
The 4b and 5b to get?
9B.
9b. Now, the 9b squared has no friends. Where do I put that?
Before.
Before the positive 9b, because it's a higher power. We're getting descending order, second power, first power, and then at the end we'll put our friendless -2. There we go. Number 34, what can we combine together? Luciana?
Combine 34AB and -12AB.
To get?
Positive 22AB.
And then the friendless term is the
5A.
5a. Here it doesn't necessarily matter before or after. We'll put it after because this has two different exponents of 1. This only has one exponent of 1, so technically this has a higher power because it has 2 of them. It doesn't really matter on that one. I'm not going to stress that one too much. How many had that answer, though, or those answers on 22 through 24? Questions at all on that section with the combining of like terms and placing them in conventional order? Let's drop down to the bottom now. This goes back to some things we did way back in the last semester. The start of this semester, right after we came back from Christmas. Translating into algebra. Number 25, the product of 5 and y. What does product mean, Elaine?
Multiplication.
So how would I show multiplication between 5 and y?
5y.
5y, good. We could say 5 dot y, we could say 5 parentheses y, but mathematicians are lazy, and I want you to be as well, and just put 5y. Number 26, the sum of w squared and y squared. What does sum mean, Michael?
Like add.
Adding, okay? So that means we're going to add a couple things together. It says the sum of. So we're going to add a couple things. What two things are we going to have to add?
W squared and y squared.
How would I show w squared and y squared being added together?
Put w squared first plus y squared.
There we go. W squared plus y squared. How many had that for number 26? Number 27, 12 added to d. How would I show 12 added to d? Ben?
12 plus D.
12 plus d. Or you might be like, well, it sounds like we had the d first, and then to the d we added 12 more. Does it matter which way we write it, class?
No.
Technically, no. Addition's commutative. Either answer is good. Number 28, 6 less than a. Let me say that again, but a little differently. 6 less than a. Class, I told you when you see the word than, you need to flip it. So, Corey, what should 28 be?
8 minus 6.
Good. We know that less than means subtraction, but we're going to start with the a and subtract away the 6 from that a. How many had that in the right order? How many had 6 minus a? All right, just a good reminder for us. Okay, then look at number 29. 5 less than m. All right, you three that missed the previous one. What should number 29 be, you three?
5 minus m.
M minus 5, because we got to flip it around. M minus 5 for number 29. Number 30. There's that word again. 20 more than x. So, Kirsten, what's the correct way to write number 30?
X plus 20.
X plus 20. Now, on this one, though, if you wrote 20 plus x, is that wrong?
No.
No, because addition's commutative. So you would be off the hook here. But the best way, the way I want to get used to, just so that we don't miss it on the less thans, is anytime you see the thing, be in the habit of flipping it so you don't miss it when it matters. But technically, this one, it would not have mattered. Questions on the 25 through 30? Anyone perfect on all of those 25 through 30? Anyone perfect on the whole homework exercise? A couple of you. Anyone just miss 1 or 2 on the homework? Just miss a couple on the homework. Any questions at all on the homework? Right above the homework, do that little tiny review section, 63 to 68. Let's practice with just a little more of this algebraic translation. Take about a minute and a half or so to do these 6 translations. Several people already finished. Take just another moment longer. All right, let's see how we did. Number 63, 4 less than A, Elaine.
A minus 4.
A minus 4. Number 64, twice X, Kirsten.
2x.
2x, twice means times 2. And so instead of 2 dot x or 2 parentheses x, we'll just say 2x. Ooh, number 65, the ratio of n to 5. Jalen.
N over 5.
N over 5. Ratio means make a fraction out of it. N over 5. Very good. Number 66, the product of 6 and y. Joel.
6y.
6y. Number 67, the sum of 7 and z. What you got, Ben?
7 plus z.
7 plus z. Ooh, and number 68, they made you think on this one. W exceeded by 11? Exceeded by? What does it mean if something is exceeded by, class? Something is bigger or it goes beyond, right? Exceeded by. Like if the Cardinals score 3 runs in a game and their runs are exceeded by 11 by the other team. How many runs did the other team score? Not 11, 14. We lost by 11 runs. That didn't actually happen this time. But anyway, if that had been the case, it seems to happen with frightening regularity with my Cardinals. But anyway, if our runs were exceeded by theirs by 11, then that means they went 11 beyond what we had. So, W exceeded by 11, volunteer. Corey? W plus 11, very good. Anyone perfect? 6 for 6 on those. Questions on those? All right. Right above the review section, we've got some more of these polynomials that need to be simplified and then put into conventional order. Do numbers 54 to 62. Do numbers 54 to 62 at the very top of the page. Combine like terms and put this in conventional order. I got it. Look in the section at the top of page 4. What you're looking for are any terms that are like to each other. They've got matching letters, or here, their letters match that. That makes them like to each other. So, and we'll combine the things that are like to each other. If they're not, if they don't have any like terms, just leave them. The way I taught it yesterday is, even if you ain't got no friends, you still exist. Nobody to hang out with, nobody to combine with, but you still exist. Okay, so same thing with the polynomial terms. Don't drop them just because they ain't got no friends. So we're teaching this around Christmas time. I did, Island of Misfit Toys analogy or something. Bless you. It's explosive. It's more explosive than the Colts offense. And we didn't make it any better last night. Maybe we got a pass rush, though. We'll see. That was more like the Colts offense. Oh, man. Tonight what we need in the draft is some offensive playmakers, if there's still any left. And there's a few, I think, who could be difference makers. And then need my Pacers to hit their threes tonight.
No.
Take down the Bucks.
I'm just worried about baseball right now. Braves are killing it.
Cardinals are just getting killed, so, Right now, the draft is more entertaining than the baseball season. Once we get in the middle of the summer, though, and baseball's all I got left,
Well, it's also
Peter,
our,
take the car.
we have the best win rate right now.
The Denver's about to beat Lakers for
Did you just say the Denver?
yeah.
Cause
That
Denver's
sounds
up
weird.
3-0.
Already?
Yeah.
Man,
The
that's
Lakers about to
LeBron done.
No, it's not his fault. It's not LeBron's fault. It's his team's fault.
LeBron my king.
All right. Yes, ma'am. Go for it. Take about 30 seconds longer to finish up this top section. Focus, Michael, focus. All right, let's take a look at these together. Number 54, what do we combine together, Joel?
we combine the positive 6 and negative 5.
Good, the two constants can be combined to get
Positive 1.
+1. Nothing else combined, so we just have to leave it. How do we write our answer in conventional order?
3w to the fifth power, positive 4w positive 1.
There we go. So a couple of things here that I didn't get to mention earlier to you, Griffin. With conventional order, if we have the same letter recurring, we want the biggest of its kind first. For instance, w to the fourth, there's actually 4 w's. We want to put that first. Here there's only 1 w, that's a smaller amount of w's. We put that next, and the constant always has no letters, right? So that's always going to be the lowest power. We always put the constant at the end. Okay, so the conventional order would be that. Now, if you put the positive 1 first, and then you listed the rest of it, you hadn't heard that yet, you hadn't learned that yet, but we'll always put the constant at the end and descend the other letters if they're matching letters. So for instance, on number 55, Griffin, what combines?
18x squared and 7x squared.
To get?
I think I got it all wrong. So,
Don't worry about it, just focus on what I told you to do right now. 18x squared plus 7x squared, what does that give us?
95. No,
What's 18 plus 7?
I didn't. Okay.
I don't know, we're adding, it's plus, right? Plus 7. You got 18 bucks, somebody gives you 7 bucks, and now you got how much money? A lot?
25.
25. Okay, so that gives us a 25x squared. Does that make sense? All right, now, Griffin, does the negative 4 have any friends?
No.
Does the positive 3x have any friends?
No.
No. So we've combined what we can combine. Now notice, x squared is the biggest power of x. The next thing I should write should be the next highest power of x, which would be which term?
3x.
The positive 3x. And we'll put the constant at the end, so we'll write our
Subtract.
negative 4. We'll write the negative 4 at the end. Does that make sense?
Mm-hmm.
All right. Looking at number 56, what combines together here, Bryson?
3A and the negative 5A.
Good, the 3a and negative 5a combined to give us what?
2A.
Careful, keep the sign of the greater. Negative 2a, there we go. And then where do I put the a squared?
You put it right in front of the negative 2A.
Good, put it at the beginning, and then where do I put the negative 5 that has no friends?
At the back.
And this way we have what order class?
Descending.
Descending order. A squared, then it's a negative 2a, and then it's down to a negative 5. Looking at number 57, what can combine together here, Luciana?
5b and 12b.
To get?
17b.
And the negative 3 has no friends. Where do I put it?
At the end.
At the end. Looking at number 58, what combines together, Michael?
58, 14R and 6R,
To get?
20R,
But we can also combine what else, Michael?
8 and 7.
Oh, careful, not 8 and negative 7, good. And 8 and negative 7 combine to give us a,
Positive 1,
where do I put it?
after the 20R.
At the end, after the 20R. There we go. Number 59, we can combine what together here, Corey?
13G and negative 20G.
When we combine a 13G and a negative 20G, what do we get?
Negative 7G.
Negative 7G. But we can also combine, Corey, the,
Negative 9 and negative 2.
to get?
Negative 11.
Where does that go?
Behind.
Behind it. There we go. Excellent. Number 60. What can we combine? Elaine.
The 9n and the 4n,
The 9n and negative 4n to get
5n,
5n. We can also combine
3 and 15,
to get,
18,
which we put,
after the 5n.
there we go. Looking at number 61. Let's go back to Griffin. I can combine the
8v and 5v,
negative 5v to get
3v,
3v. And I can also combine,
negative 30
good,
with positive 5,
good. I like that you said negative 30 and positive 5. Excellent. What do we get when we combine those?
25,
Keep the sign of the greater.
negative 25.
Negative 25, and we'll put it at the end so that we have the constant at the back. Looking at number 62, what can we combine here, Jalen?
Yeah.
What can we combine together?
9s squared and negative s squared.
Good. And what number is technically the numerical coefficient in the negative s squared?
1.
A negative 1. So we have a 9s squared and a negative 1s squared gives us 8s squared. We can also combine the
8 and negative 12,
to get
negative 4.
negative 4. How many had 8s squared, negative 4 on that one? Anyone perfect? 9 for 9 on this top section. Anyone just missed 1 or 2? Any questions on the 1 or 2 you missed? All right, Griffin, questions on this stuff?
I think I got it.
Think you got it? It's okay. We got plenty more practice coming up here in just a moment. Turn over to page 407. Flip over a page 407. And in the homework section, do 21 to 28. Page 407 in the homework section. Do numbers 21 to 28 there at the bottom of the page. '21 and 22 kind of take us back a little bit. Some old good review for us here and a little bit of a break from simplifying polynomials. They tell us what x and y are equal. We got to plug those values in and evaluate. It's been a little while since we've done this. Some good review. We did have one exercise, I think, like this in our financial literacy supplement, I think. And that's been a little while. Remember, when you plug them in, I would suggest putting parentheses around the numbers as you plug them in. Solve it. Just, okay, put your pencils down. I think we have completely forgotten what we're doing. Let's suppose we have A is equal to 2, B is equal to negative 3, and C is equal to 5. And we've got an expression 2AB minus 3C. What we're going to do, class, is instead of an A, class, we're going to put 2, because that's what A is. But I'm going to put it in parentheses. And for the B class, we're going to put negative 3, but we're going to put it in parentheses. Then it says minus 3 times C. Well, in parentheses, class, we're going to put a 5. Now we're going to follow order of operations. What are we supposed to do next, class? Multiply stuff, right? 2 times negative 3.
12.
Negative 12, because there's one negative. And then negative 3 times 5, negative 15. And then we'll combine these two. The negative 12, negative 15 gives
Negative 25.
negative 27. There we go, negative 27. Do you remember this now? It's been a little while now that we remember this. Do 21, 22, and then, of course, some more of that simplifying polynomials through 28. Taking this opportunity to review algebra. Some stuff we've talked about earlier, some stuff we're talking about now. As I said yesterday, I want to shore up the algebra side of things before pre-algebra next year. All right, for sake of time, pencils down, look this way. Number 21, check your initial step. And by the way, you do get partial credit on a quiz or test just for plugging in the numbers in the right spot. Did we plug in the -6, -8, minus 4 times -6, -8? Did we get that? So all we gotta do is multiply. Well, negative times negative, class, positive, and then 6 times 8, 48. But look at this one. I've got 3 negatives. What's the rule with 3 negatives?
Negative.
It's negative. That's an odd number of them. Or you could say, well, 2 of them give a positive, but then it's negative here. So we're going to get negative something. 4 times 6
24.
times 8,
192.
192. So I have a positive 48 and a negative 192, and we combine to get negative 144 is our answer there. Now, how many had negative 144? Just a few of you. Questions?
44.
Questions on words. Look at the next one. Don't forget the 100. Oh, looking at this one, next one. Did we plug in the 11, the 9, and the 9? But order of operations is not going to start with multiplication this time, class. It's going to start with the exponent. What does 9 squared actually mean? 9 times 9 or 81. So this becomes 7 times 11 plus 4 times 9, negative 3 times 81. Well, 7 times 11, class. And 4 times 9. And negative 3 times 81. Negative 243. What's the problem, Bryson?
We just left the way I said 77.
Control yourselves. I know we're tired. Just control yourselves. Looking over here at the positive numbers, we can combine 77 and 36 to get what, class? 113. And that's a positive 113, right? But we got a negative 243, so put a positive 113 with it, and we get what for our answer? Negative 130. Negative 130. How many had that answer for number 22? It's been a little while. Questions on that stuff? All right, now for the more recent stuff. Number 23, what was your answer, Joel?
28D.
28D. Number 24, Michael.
Negative 8A.
Careful, keep the sign of the greater. Positive 8A. Number 25, what do we get for our answer, Ben?
I didn't get 20.
Well, let's see what we can combine on 25.
The 5 and the 2.
The 5V and the negative 2V to get
30V.
3V. That's a positive 3V. Does the 4G have any friends?
No.
No, where do I put the 4G?
At the end.
Is that alphabetical? Does V come before G in the alphabet?
No.
So, Griffin, if you have different letters, you're going to put alphabetically first. So we're going to put the 4G before the 3V so that they're in alphabetical order. Looking at number 26, what did you get for your answer, Corey?
Negative 2n cubed plus 4n squared.
Now look at your 2n cubes. You have a positive 3n cubed at the beginning, and later on you have a negative 1n cubed. We want to keep the sign of the greater.
2n cubed plus 4n squared.
There we go. A positive 2n cubed, and then the positive 4n squared. Number 27, Bryson.
19c squared and 4c.
What? Say that last part again.
4c.
Positive or negative?
Oh, positive.
Positive, because we keep the sign of the greater. So 19c squared, positive 4c. Number 28. What do we get for our answer, Kirsten?
23A, positive 3B, and positive 19.
Good. So notice here, Griffin, we can combine the 29A with the negative 6A. That's 23A. The positive 3B has no friends, but because B comes after A in the alphabet, we put it next. And then we'll put the positive 19 at the very end because it's the constant. Questions on that? Anyone perfect on all the ones you did on that assignment? Even if you didn't finish all of them, perfect on the ones you did. All right, turn the page. Do numbers 29 to 34, a little bit more algebraic translation. Do a little bit more of this algebraic translation, 29 to 34. Again, take about a minute or so. Really trying to shore up our algebra, reviewing some things from earlier in the year, while still working on some new things. 29 to 34. Number 29, what do you have here, Jalen? A over 2. Number 30, Elaine.
3W.
3W. Number 31, Luciana.
D minus 18.
D minus 18 or D negative 18. Number 32, Ben.
G5.
I'm sorry?
G5.
What does more than mean?
Multiply.
Oh, it does not. If I have $5 more than you, doesn't mean I have 5 times as much.
Add.
Okay, so what should we have?
G plus 5.
G plus 5. There we go. Number 33, Michael.
8 minus R.
8 minus R. Difference of means we're going to subtract. We just assume we keep the same order unless there's a word like than or from to tell us otherwise. And number 34, Joel.
3 plus B.
3 plus B. Questions on those? All right, last set of exercises. Go down to 47 to 52. 47 to 52. All right, number 47, check your answer, 16W. Number 48, positive 1P cubed, or just P cubed, because we're lazy. Number 49, 12D to the 4th. Number 50, 17R, positive 3W. Number 51, 5P, positive 8Z, negative 6. And number 52, 13A squared, positive 5A, positive 12. How many perfects? 6 for 6 on those. Any questions on those? All right, homework for this evening is to do page 407. Page 407, the review, 43 to 59. Page 407, the review, 43 to 59. We have a test coming up on Wednesday in lesson 163. It'll be all the graphic stuff we talked about and some algebra as well. Have a wonderful weekend. Have a wonderful rest of your day. You are dismissed.